All right, so here we are. We're in the middle of doing this last example here with the quotient rule. And let's continue on here. So remember, we just discussed that the bottom, you do not have to expand. The top, however, we need to simplify it. So we're going to distribute that 2x to all these terms. So we get 2x to the fourth plus 2x cubed plus 4x. And then we're going to do minus, and let's put that in parentheses so we remember to distribute that negative sign. And then we get 3x to the fourth plus the outside, which is here. Let's zoom it back out. The outside, which is 2x cubed. The inside plus 3x squared. The last is 2x. Okay, and then we have to distribute that negative sign. And remember, we're keeping that bottom the same exact way. We're not doing anything to it. We could expand it, but it's not going to give us any new information. So 2x to the fourth plus 2x cubed plus 4x minus 3x to the fourth minus 2x cubed minus 3x squared minus 2x. All over the bottom squared. Let's combine like terms and then we'll be done. So we have 2x to the fourth minus 3x to the fourth. So we have a minus x to the fourth. 2x cubed minus 2x cubed, those cancel. We get a 4x and a minus 2x and minus 3x squared. So plus 2x over the bottom squared. Last thing we want to do is we see that numerator has an x in every term, so let's factor that out. We got a minus x cubed minus 3x plus 2. And there we go, we found the derivative. Okay, I made this one slightly complicated on purpose. But just keep in mind, you plug in the formula into the quotient rule and then simplify the top and keep the bottom the same. Let's do another one of those. All right, we're going to let y equal the square root of x over x plus 1. Okay, so the quotient rule. So the top function is the square root of x, and the bottom function is x plus 1. We can go off to the side again. Remember, you can write the square root of x as x to the 1/2. We take that derivative. We bring down the exponent. We got x, and then we have 1/2 minus 1, which is x to the negative 1/2, which is 1/2 the square root of x. Bring it down to the denominator. Now we have g of x. It's x plus 1. The derivative of g of x is 1. So that's pretty nice. Okay, so let's take our derivative here. We know we got to use the quotient rule, so let's write it out. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, now for the bottom, it's x plus 1 times the derivative of the top, which is 1 over 2 square root x. Then you subtract the top, which is the square root of x, times the derivative of the bottom, which is 1, over the bottom squared. X plus 1, quantity squared. And then, now we just have to focus on simplifying the top here. So the top is x plus 1 over 2 square root x minus the square root of x all over x plus 1 quantity squared. Now let's write that as one fraction. So we have to multiply this by 2 square root x over 2 square root x. And we got x plus 1 over 2 square root x minus 2x over 2 square root x when you multiply across. And then in the bottom, it's just along for the ride. So then up top, we got x plus 1 minus 2x over 2 square root x over x plus 1 quantity squared. Then we got x minus 2x, so that's a minus x plus 1 over 2 square root x over x plus 1 quantity squared. Now it's a fraction over a fraction, so we're going to multiply by the reciprocal. So we got, instead of negative x plus 1, I'm going to write 1 minus x. It looks nicer, over 2 square root x, and then times the reciprocal, which is 1 over x plus 1 quantity squared. And so officially we have 1 minus x over 2 square root x times the quantity x plus 1 squared. And there we go. That's our derivative. Okay, so where are we headed? Well, now that we can take derivatives real nice using these rules, we're going to do that, and we could even find a tangent line, the equation of the tangent line if I gave you a point. So that's still the same. Remember, the derivative is giving you the slope of the tangent line, and then where we're going to head in the future is find the derivatives of the remaining trig functions. Thanks for watching the videos, and I'll see you in class.